First up is our good friend, Sean Lahman. Sean is the creator of the Lahman Baseball Database, an open source collection of baseball statistics. He has been an editor and contributor for more than a dozen sports reference books and serves as the data projects manager for SABR. Today, he'll be providing us with an introduction to baseball databases. Sean, my friend, good to have you back. Take it away.
Thank you, Scott. And hello, everyone, and welcome. Glad to have you here with us today. I'm going to talk today about baseball databases and how to work with them. It's an introductory view. It's aimed at folks who maybe have dabbled with databases a little bit, or even folks who haven't really worked with them at all. And my hope is that this conversation can serve as a jumping off point for folks who want to do a lot more. I'm going to give you an overview of some important concepts, and we'll walk through a bunch of examples. The goal is that at the end of today, you'll have enough information to be dangerous. If you want to get started working with databases on your own, if you want to move forward and develop some more advanced skills. I'm going to be using Microsoft Access with the Lahman Baseball Database. If you want to follow along at home, you certainly can. Let me bring up my screen here and we'll get started. There we go. So the link here is just a way to get in touch with me. If you have questions later, you can also go to that website and download the database if you want to. If you want to just watch along, that's okay too. We're going to be focusing on broad concepts today. So let's start by talking a little bit about what a database is. Most folks will say it's a collection of data, but that's not entirely correct. A database is a way of organizing that data specifically to make it easier to analyze and extract meaningful information. When we create a database, what we're doing is designing a set of rules that will govern how the data is collected and stored, and the rules are what make complex analysis possible. One of those common ways of working with data is with spreadsheets, and you may be familiar with Microsoft Excel or Google Docs as examples of that. And for many purposes, spreadsheets are an adequate tool. You can make manual entries. There's no need for really strict rules. And you can use the basic tools of a spreadsheet to sort. This is just an example of World Series winners. And you could find out from this list how many times each team has won a championship. So spreadsheets are good for simple lists and simple queries, but you need a database to do more complicated analysis and to work with large collections of data. So what if we wanted to ask more complex questions, say, looking at the correlation between how many wins a team gets in a season and the likelihood that they'll win the World Series, or how many teams led the league in homers but failed to make the playoffs? These sorts of questions require a more complex set of data, and they require tools that really don't exist in spreadsheets. So in order to answer these sorts of questions, what database folks call queries, you need to create a structured database and work in that in what we call a DBMS, or a database management system, to make those queries. And we'll make those queries using a form of computer code called SQL, or structured query language. I'm going to walk through the basic concepts of SQL today, but what's most important is that you understand the underlying concepts here. The specific syntax of SQL takes some time to learn. It'll get easier as you start working with databases. But what's important, I think, to take away from today is the fundamental ideas of what we're trying to accomplish, and the rest will be easier for you. So for this session, I'm going to work with Microsoft Access. Now, it's not the most robust database system that's out there, and it's not one that gets a lot of respect from data professionals because it has a lot of limitations. But for learning purposes, it has a couple of distinct advantages. And one is that it's readily available. It comes as part of the Microsoft Office suite. So if you're working in a professional setting or an academic setting, it's likely that you have it available. For more robust analysis, you would need to install a series of tools and learn a programming language like Python or R. And you have to do all of that just to get started. But if you have access, all you have to do is click on the icon and you're ready to get your hands dirty and dig into a database. Another thing I like about Access is that it has a visual interface, which makes it easy to explore a database, even if you haven't learned any code yet. It's got drag and drop tools that'll help you build queries without knowing how to write code. And the tool will actually help you learn about SQL by building queries for you. So I'm going to start by explaining how some of the basic concepts of how we build a database. We'll go through these ideas once quickly, and then we'll dive in to see them in action. We talked about rules for databases and that you need them. So what are these rules? If you recall, spreadsheets are simply organized into rows and columns. A data table is a similar structure within a database where each column is what we call a field and each row is what we call a record. But each of those fields have rules. And the most important rule is to define a data type. So a field can contain a string of text, like the player's name. It can be a number, it can be a date, and of course you can even more precise defining each of those data types. A text string can have a variable length, someone's last name or first name, for example. It could be a fixed length. When we talk about whether they're a right-handed or left-handed batter, that's always a single character. The team abbreviations are 3 characters. A number can be an integer, like the number of hits, or it can be a decimal, like the batting average. Another rule we use is to define whether a value is required or not. If you have a list of players, for example, we probably require they have a first name and a last name and a birth date. But not every player will have a nickname, for example, and players who are alive won't have a death date. Another important rule is something called a key, and that's a field that helps us to group similar records together and to distinguish unique records from each other. So one example might be the 3-digit or 3-letter abbreviations that we use for each team. In some tables, such as a listing of all the teams, that's going to be a unique value, but in other cases, such as the batting statistics, that might appear dozens of times. The keys also help us distinguish between players or teams who have the same name but are in fact different. The Frank Thomas, for example, who played for the White Sox in the 90s, has a different unique key than the Frank Thomas who played for the Mets in the 60s. The purpose of the keys is to help us connect different tables together, and that's one of the most important ways that we can organize the data. So these concepts will become more clear once we dive in, but just for now, remember that we're going to organize data into tables, define data types, and then create keys to link it all together. So I'm going to show you a Lahman database and how it's constructed. This is going to be probably a little overwhelming at first, but it gives you a sense for how much information is out there in the universe and why it's important to organize it. And let me start first with a quick discussion about the scope of this database. So of all of the publicly available baseball databases, this is the one at the highest level, which means for players and teams, it's season by season totals. There's typically one record for each player season, just like you would see at Baseball Reference or in a printed encyclopedia. If you go down a little bit, if you want to look at instead of at the season level, if you want to look at game by game or play-by-play data, you'd probably work with something like the retro sheet database. If you wanted to look at pitch-by-pitch data, you could dig into something like Baseball Savant. So scope is an important concept. If you want to know how many times Joey Votto has drawn a walk on 4 pitches, or how many times Roldis Chapman has plunked somebody with a 100-mile-per-hour fastball, you're not going to find it here. And likewise, if you want to know how many times Juan Soto has been intentionally walked in his career, it's going to be a whole lot harder to try to answer that question from play-by-play or pitch-by-pitch data. So understanding the scope of your question is important. This is a visual representation of what's in the Lahman Baseball Database. Each one of these boxes is a data table. There's 27 of them, and the lines between them show how each of these tables are linked to the other through the use of keys. We'll get into some of these tables in a little bit, but for now, let's just talk about them broadly. We're not going to get too deep into principles of database design, but generally what we try to do is organize data into tables in a way that eliminates the need for it to appear in multiple places. So for example, I mentioned Joey Votto. We know that he's a left-handed hitter. We're only going to store that information in one place. We don't need to make a record of his left-handedness on every single record that pertains to him. All of the information that's unique to Votto and to other baseball players is stored in this table called people, and that has their date and place of birth and height and weight, full name, etc. This people table is one of the most important ones in the database, and you can see it's got a unique key here that's called player ID that we assign to each player, and that links up to the other tables. So I'll take a quick run through what these tables are. The main statistical tables are here, and they're probably what you would expect: batting, pitching, fielding statistics. You'll notice there's also separate tables for postseason data: batting, pitching, and fielding. So you want to do a query to find out who's hit the most home runs in the World Series, for example, you can do that. We have a couple of extra tables for fielding statistics. So before 1955, the official statistics lumped together the three outfield positions into a single category. A guy like Babe Ruth played games in left field and center field and right field. The official stats kind of clump that all together just as outfield. So this fielding outfield table has a breakout of how many games each of those outfielders played, left, right, and center. And the fielding outfield splits has some more advanced fielding data that we've derived from RetroSheet data. I could do a full hour just talking about the complexity of fielding data. We'll do that maybe in another session, but I don't want to get sidetracked too much. I will just mention this other table here. It's called appearances, which just tracks how often a player appeared at each position. A lot of that information is in the fielding table, of course, but this table also includes how many times somebody appeared as a designated hitter, or pinch hitter, pinch runner, that kind of thing. We've got a separate table for managers. It has their year-by-year managerial records. And just as with all the tables for players, each one here has a corresponding record in the people table with their full name, their birth date, and so on. So this people's table is a pretty important one because of everything that's related to it. You see all those lines coming out of there connecting with the other tables. The same thing is true of this teams table here, which contains the year-by-year data for every team, their won-loss record, their position in the standings, team totals for batting and pitching, and so on. Team franchises is how we keep track of teams as they move or change names. It's how we can tell the California Angels and the Los Angeles Angels are the same franchise, Seattle Pilots, Milwaukee Brewers, etc. There's a home games table here that keeps track of how many games each team played and where. Each season we have games played at neutral sites for a variety of reasons, and that's a good way to keep track of that. Table here called Parks, which has more details on each stadium, helps you keep up with the changing names, among other things. And last but not least, the series post table has details on each playoff series, which team won, which team lost, how many games each team won, pretty straightforward. So those are the 16 tables that are the core of the database. I'll just go through a bunch of the other supplemental ones real quick. Hall of Fame has vote totals for each year's Hall of Fame ballots, a quick way to look up whether somebody's a Hall of Famer or not. All-Star has a data on every player that was selected for an All-Star game, whether they played in the game, whether they were a starter, and then salaries, which is admittedly an incomplete collection of public salary data. There's 4 tables for awards. with manager awards and player awards stored separately. Awards players and awards managers, they list the people who won the manager of the year, MVP, Cy Young, etc. And the award shares for players and managers, they have voting breakdowns. So if you want to find out how many Yankee players have won an MVP award, you get that here. If you want to find out how many got MVP votes, that's in the shares table. And finally, there's a table up here called college playing. That's just a list of, there's no playing statistics there. It's really just about where and when guys played college ball, those that did. And this table called schools has a little bit more information on each school, their name, where they're located, etc. I'll mention two more that really aren't used that much, but they're here for historical purposes. This managers half and teams half. They're related to split seasons, which, as you probably know, are more common in the minor leagues, but they've happened a couple of times in the majors. So that's a real quick overview of this entire universe of information. I'm going to switch over to Access now, and we can start to dive into it. All right, I'm hoping you can see Microsoft Access here. If you haven't looked in this before, it's maybe seems a little daunting at first, but it's really not that complicated. Over here on the left is just a list of those tables that we talked about, a little bit different view. All you have to do is click on one to see what's inside of it. So I'm going to click on the people table here that we talked about. And you see that's a list of players and information about them. We talked about data types. We talked about how you can define a field as a date, but you've noticed here that we've stored birth date as 3 separate fields. And the reason why we do that, if you scroll down, you'll see some examples. A lot of 19th century players, we just don't know when they were born. We know the year, but maybe not the month and day. And so we store that as 3 separate fields there. There's hundreds of those guys. Players who don't have a death date, that typically means they're alive. Let me scroll over a little bit and we can look at it. These fields are mostly pretty self-explanatory. We have here the debut date. We store this as a date rather than splitting it out into 3 fields with the birth date, because we always know the full day of when they made their major league debut. It's not a guess. And we also have this final game category too. This gets updated every year, so every player has a value here. It doesn't necessarily mean they retired. It just means we keep track of when their last game was. In this country, we usually express height in feet and inches, but that gets tricky if you store it as a string. Say 6-2 is maybe how we would write it out. Then you can't perform mathematical functions on that value. If it's a string, you can't do a query that asks for the most home runs by a player under 5'10". So we convert that value to inches. And one more thing I'll just mention, we talked about the key that's over here. This is unique to this database, but for each player that's here, we've also, over here at the end, you'll see, we've also provided a key if you want to link it to records in the RetroSheet database or over at Baseball Reference. Let me, let's close that. Let's open up the batting table and take a look at that. Again, you just click on that to bring it up. Most of these categories, again, are self-explanatory. But let me just point out a couple of things. This field here called stint, when a player appears with multiple teams in the same season, say through a trade or through the waiver wire, this tells us the order in which those stints appeared. Most guys only play for one team in a year, but it happens. That can be helpful for all sort of reasons. And as you look at the data here, you'll notice that some of these fields are blank. And again, for 19th century players, they didn't track things like hit by pitch or caught stealing, sacrifices. And so there's a difference between, if we look at one of these players, there's a difference between not knowing how many times this guy got caught stealing and knowing that he got caught stealing 0 times, right? So it's important, if you're going to calculate stolen base percentage, for example, that you know that. There's gaps in our data for early game. Let me open up the pitching table and we'll take a quick peek at that one as well. Again, most of these fields are self-explanatory. Again, you'll see some gaps for 19th century players. We talked about how in the people table that the height field is converted to inches. You can notice that we do the same thing here with innings pitch. We convert that to outs. Baseball has been wildly inconsistent in how it expresses fractions of an inning in its official records. If a guy pitches 8 1/3 innings, let's say, sometimes in the box score that'll be expressed as 8.1 or 8.3. Sometimes I'll use a fraction symbol. Those are fine for displaying in a box score, but you can't do math that way. If the pitcher goes 8 1/3 innings one night and has another innings that's 2/3, 8.1 plus 0.2 equals 8.3, that's not right. So the solution here is to store innings pitched as outs, so you don't get into those computational errors calculating ERA, that kind of thing. 1 inning is 3 outs. And since you can do mathematical operations, you convert that back to innings if you want to display your results. Those are just a few examples of the kind of rules that make a database like this function. I'm not going to go through all 27 of the tables, but as you explore, you'll come across some more examples. And let me just say, when you download this database, there's a README file with it that explains what each table is, explains what each of the fields are in case some of the abbreviations aren't intuitive. This is what we call a data dictionary, and it's a great place to start when you're working with this database or any other. So let's look at one of these tables and start to build some simple queries. And I'm thinking, let's start with the teams table, which we talked about. Each record is information on a single team season. As you see, there's a lot of information here. I think maybe 50 fields. It starts with their won-loss record, and we get into batting statistics, pitching statistics, etc. So this is what Access calls the data sheet view. We're just looking at the data that's in the table. But you can come up here to your home menu, click on Design, and that'll show you the rules that have been put into place, how we've designed this specific table. And you see here that the field names are self-explanatory, and they have a data type that's defined. Year is a number, league and team IDs are each text strings, and if you click here, the league ID down here, it says field size of 2, AL, NL, those are our team abbreviations. Team IDs are typically 3, and so on. This is a good way to familiarize yourself with the rules that have been set up and understand how the data is organized. It's also helpful when you want to build a query and try to understand how to access, how to get at the information that you're looking for. So before we do that, let me go back just a moment and we'll talk about how to build a query, and then we'll come back here and we'll do one of those. So bear with me here. Typically, a query is going to have 3 or 4 parts and maybe more. And the first thing that you need to do is to understand which field you want to see in your results. You can look at all kinds of things, but let's go back to the example that I used of a list of World Series winners. So if we want to do that, what are we looking for? We want to know the name of each World Series winner and which year they won. So to do that, to build that query, we'll start by selecting those two fields. And then you need to specify what data table you need to answer your question. You're not going to get a list of World Series winning teams from the batting stats. It's going to come from the teams table. So that's what in SQL we call a from statement. But we don't want a list of every team, right? Just a team that won the World Series each season. And conveniently, as you saw, we have a field that tells us that. We only want the records where the field returns a particular value, in this case, a yes in the World Series winner field. And for ease of reading, you can decide to sort your results in any order. In this case, probably chronological order, right? So let's go back to Access and we'll build one of those. All right, let me close this. So to build a query, we're going to just go up here, create query design. So first we'll choose the from, and as we said, the table we want is teams. I'm just going to click on that and drag it up there. And then we will just drag and drop the values that we need. You can drag and drop or you can double click. So we want year, and we want the team ID, which is their 3-letter abbreviation. And then we only want the ones who have won a World Series. So we're going to specify that here as a Y in that value. And then, oh yes, we're going to sort them by year. And we're going to do that in descending order. So the most recent ones are up top. Now, before we look at the results, which are not going to surprise anybody, I'm going to show you how Access will show you how to build that query in SQL. We click Home on the main menu, and we click SQL View. This may look just like what we were talking about before. Select specifies the 3 fields to show on our results: year, team, and World Series winner. The where tells you we only want the ones where the value is yes, and then the sort order. So when we go to the view, there you go. Let's go back to the query now and make this a little more complex. Go back to our design view. Let's make a query to find out which teams have won the World Series with the fewest wins in the regular season. So we'll select another field here that we want, which is wins, right? And let's add the number of games that they played just to give some context. It hasn't always been 162, as you know. And then rather than sorting it by year, what we'll do is sort it by wins, because we want to know who won the World Series with the fewest number of wins in the season. And we go here and we'll click on our data sheet view. Whoops, I did most. Let me go back and do, we want ascending. So there you go. And as you see, the Dodgers have 2 World Series wins in seasons that were shortened for different reasons, and then the 1918 Red Sox. And again, you can go back to this tab here, SQL View, and it'll show you how to construct that query. We added a few fields to our select statement. We changed the order by statement. Otherwise, it's the same as before. And let's do one more by changing a few things. Let's query for teams that did not win a World Series, but see who had the most wins. So all we're going to do is change the criteria in our where statement from a yes to a no. And then we're going to change that again. And then we're going to change this to descending. And then you have the 1906 Cubs, who lost the World Series to the White Sox. You have the Mariners in 2001, who lost the ALCS to the Yankees. A couple of things I should mention here about working in Access before we move ahead. When you're running queries, you're almost always in a read-only mode. You can't accidentally overwrite the underlying data, so feel free to tinker around and create queries like this and look at the SQL view. It's a great way to learn, and you're not going to break anything. You can also go directly into the SQL view and make changes here if you want to. Let's try one example. Let's change the where. So we're getting teams that won the World Series. Let's change that to a Y. And let's get rid of the games field here. Now, I'm going to make a mistake here just to show you what happens. If you leave that comma there, you make any other mistake here, and you try to view it, Access is going to tell you you screwed up. But that's why the drag and drop is a good way to learn, and I think probably most people use Access that way. So I've covered a lot of ground here. Let's get into something a little more complex. I'm going to close this here. Let's take a look at, let's make a list of players who hit the most home runs in a single season. The approach is generally the same as what we did for a list of World Series champions. We'll start by creating a new query. We're going to need the batting table since we're interested in looking at home runs. So I just drag that over here. We'll select a few fields. Let's say the year and the player ID and number of home runs. We want to do that in descending order because we want to see the most. And there you go. Bonds, McGuire, Sosa built that list pretty quickly. Two quick notes. First of all, we're displaying the ID, not the full name. So in some cases, you may recognize that that's Barry Bonds. In other cases, you won't. We'll come back in a minute and I'll show you how to change that to their actual names. The other thing I'll mention is we didn't select any criteria for our where statement. So as a result, this isn't just a list of the top leaders. It's literally the home run total for every player's season. As you see here, 112,000, including all these guys who had seasons with no home runs. That's a little bit unwieldy. So what we would typically do is create what we call a limit. We can do that in our where statement. So let's say we only want to see players who hit 50 or more home runs. And there you go. That's a much more reasonable list to work with. 40 guys who hit 51 homers or more. I'll mention another thing real quickly since we're here. We talked about how this is drag and drop. You can move fields around. Maybe you want to just click on this and put home runs over to the left. You can also change the sort order. So let's say you want to see who were the first people to hit 50 home runs in the season or the most recent. You can do that right here just by clicking. You don't have to actually do the code. So what if instead of single season leaders, you want to look at career records, the all-time home run leaders? The batting table, as you recall, has a list of season by season totals. So to get career totals, you're going to need to group those. So let's go back into the design view here. And we're going to click on this button up here that's called totals. That toggles this field on and off. It's usually off by default. And what we want to do is we want to group the players together. We're going to get rid of the year field because we're not going to look at individual seasons. We're looking at the entirety of a career. And what we want to do for each player that we've grouped together by their ID, you can do all kinds of computations here. We want the sum, right? We want to see who has the most. And There you go. The names that you would recognize at the top. So we'll take a quick look at the SQL statement that we created here. It's very similar to what we've done before. The big difference is that we have this group by statement, which tells Access to group the results. So there's one result for each player ID. In this case, it carried over our limit of at least 50 home runs in a career for our list. It shouldn't take you too long to become proficient at building these simple types of queries in Access where you're working with one table at a time, but let's look at how you can query multiple tables at the same time. We talked about how this may not be so readable if you're just looking at the player ID. So I'm going to show you how you link that up to the people table. Remember, in the people table that has first and last name, height and weight, all of those kinds of things. So if you want to display the player names here, or if you want to see who's the leader among active players, or who has the most career home runs for somebody born in California, you do that by querying the batting table and the people table at the same time. And so I'm going to click here on the people table, drag that over to our workbench here, and you'll see there's a line between them. That's because Access knows that the tables are linked, how they're related to each other. So we'll just, to add some names here, we'll scroll down. We'll do add last name and first name. Go back and look at our results. Much easier to read. So going back to what I said at the outset, this type of query is only possible because we put rules in place, because we created keys, and because we know there's a corresponding record in the people table for every record that exists in the batting table. This is called a relational database because the rules allow us to define the relationships between different sets of data, and that's really the power of where you're going to be able to do the more complex analysis. So let's put another spin on this. Let's change our query so that we can see which of these hitters was a right-handed hitter or a left-handed hitter. So we'll add this field here called bats, and let's set that to L for, that's our abbreviation for left-handers. And there you see there's the list of most career homers by a lefty. Or you can change that to use B to indicate somebody that bats left and right. Some other databases use S for switch hitters. There you go. So I think we've got time for maybe a couple of other examples, but before I get into any of that, I'm gonna stop sharing my screen and we could see if you've got any questions.
I have a quick question.
Go ahead.
So I know like with a lot of I'm kind of like just getting introduced to a lot of like the baseball database set and everything. Do y'all use a lot of NoSQL or is it mostly just straight relational database work?
Well, it depends on what you're doing. It really does. I think if you want to get into complicated analysis, if you're looking at, if you just want to look at pitch design, or if you just want to look at, say, situational data from RetroSheet, it doesn't have to be relational database. The challenge becomes as we've started building larger and larger data sets. You know, if you look at the baseball savant data, there's dozens of maybe hundreds of fields that are captured for every pitch. It gets to be awfully complex to try to do computations on things that size. All you're looking for is, you know, who threw the fastest fastball or who's got the most spin on their pitch. You may not need to do that. And as I said at the outset, there's opportunities to do analysis of less complex data sets in something like Excel. You don't need to necessarily bust out into a full relational database, but you know, that if you want to do more complex stuff, that's where you go.
Cool. Thank you.
Yeah, you're welcome. All right, I'm looking at the chat here. If you got, let me also say, I'll put my my information up again. If you have questions, if you start getting into this and get lost or need some help, please feel free to reach out to me either through my website or on Twitter. And I'm happy to help, happy to answer questions. And you know, this is the kind of thing that it may make more sense when you try to get your hands on it than watching somebody else do it remotely. Tim's got a question here. He asks about insights into changes to Access or new SQL programs that might be used in the future. I don't have a lot of insight on that. As I said at the outset, Access, I think, is a good, if you're not familiar with databases, it's a good place to start because it does have the visual tools you can drag and drop. If coding is not your strength, you don't need to write any code. You can use the visual tools and do queries. You can import other data sets if you want to, say, connect this data to the RetroSheet data. You can do that. That's really the power of relational databases, is it lets you connect different disparate databases and really do some complex stuff. I see a question here from Wasif. He says, as an international without much baseball experience, how do you recommend learning about the most commonly used baseball statistics, like the ones I referred to, like ERA? I don't have a great answer for that. I will say there's a very good glossary of baseball reference, which is not necessarily a course in baseball statistics, but it explains a lot of those kinds of metrics. We use things like earned run average or WHIP or slugging percentage, which are relatively easy to calculate. Other things like WAR are much more complex and probably not something you're going to do in a spreadsheet, would require some programming to do that. But I would say, frankly, Baseball References glossary is a great place to start. Jordan Wolf has a question. He says, what was the name of this particular database, and where can you download a copy of it? Go right to my website, SeanLehman.com, that are public and available. I mentioned RetroSheet. If you're not familiar with that organization, check out their site. All available for download, and they have a lot of good documentation there. And again, as you start to get into things, feel free to reach out to me, SeanLehman.com. You can contact me there, message me on Twitter or LinkedIn, whatever your platform of preference is, and happy to help. As Scott said at the outset, the baseball community is really not that big. And we have a pretty collegiate to help people get started. Ellie Mortensen has a question. Is there a way to accurately calculate WAR for college players? That is a great question. I don't know that I have the answer for that. One of the problems with WAR is that it's based on comparing players to the universe of players they compete with. And so there's some challenges there. I'm not sure how to address that, but that's a good question. I'm sure there are people out there that are working on that. I'll take a couple more questions real quick. I know we're running out on time. Tim asks, how will the automatic strike and ball calls change analytics? That's a great question that I also don't know the answer to. But that's a fascinating one because yeah, that's I'm really looking forward to, we've had two different systems for that are being used in the minor leagues. And I'm not sure there's been a lot of analysis done on what the impact. I'm sure teams have looked at that, but yeah, that's a good question. Frankly, I'm counting on some of you guys to answer some of these questions in the year ahead, next couple of years. One of the fantastic things that has been occurring, particularly in recent years, is that Major League Baseball and other organizations have provided a lot of the raw data for other people to look at and to do their own analysis. And a lot of great work has been done that way. So much of what's going on with the teams, frankly, they're looking for a competitive advantage and not always wanting to talk about the new insights they've gleaned. But the more data that's been made available, the more work smarter people than me have been doing to find out new things. And there's all kinds of questions that need answered. And again, counting on you young folks to do that. About creating visualizations through Access, which is really designed to do data visualizations with a lot of libraries built in. And so I would encourage you, if that's something you're interested in. Just as a side note, ask, would you consider SQL versus Python for analysis? Python is a, if you know how to write code, it's a pretty straightforward platform to use and to learn. There are a lot of libraries out there. There are working groups of people who use Python for baseball. Within the baseball world, I would say that there is a mix of people who use Python or R, and folks ask me a lot of times, which is the better choice? There's really, it's like asking Coke or Pepsi, I guess. Part of it is really about your personal preference. A lot of people probably work in both, but R is really aimed more at data visualizations. One of the great challenges is how do we take all of this information? How do we take a million data points and boil it down into something that's interesting and useful? That's a challenge I know a lot of teams have wrestled with. And so being able to convert that into a dashboard or something like that, it's not something you're going to be able to do in Access, but it is, I think, a very valuable area to learn some skills. Let's see. Let's see. Kanan Squibb asks, is there a common way that MLB teams choose to evaluate their players, or does each team take a different approach? That's a good question. I think there are some common tools that teams use. One of the things that's important to note is that as outsiders, as fans or observers, there's been a lot of focus on things like WAR, like boiling down all of a player's talents into a single number. But what's happened, of course, on the team level and on the individual level is they want to really dive down deep, understand not just how valuable is Hunter Green to the Cincinnati Reds as a starting pitcher, but to look at what are the elements of his game that make him successful or not. And that comes from things like spin rate, it comes from things like velocity, comes from doing more complex analysis of things like pitch tunneling or sequencing. And different teams have different approaches to that. And as I said before, a lot of that is proprietary. So those are things you're not going to hear about unless you work for a team or unless you come to a conference like this. There'll be some folks later today, excuse me, later today who can talk in more detail about some of those things. Layla asks here, what are some of the limitations of access when compared to SQL? I would say there's a few things. There are some data types that it doesn't support. There are some more complex queries that Access will not do. I recommend to people, if you haven't worked in SQL before, if you haven't worked with databases before, the visual aspect of it that lets you drag and drop makes Access great. If you're going to do really more complex stuff, you're going to have to start getting into writing your own SQL code and maybe working with one of the programming languages that I mentioned. Jordan Wolf mentions here that there's a book called Analyzing Baseball Data with R. Yes, that's a great resource. There are books out there. There are also free online courses that will walk you through learning R or learning Python in a baseball context, working with actual data. So those are fantastic resources. Those books, those websites. There are Reddit groups. There's communities of people out there that you should seek out. And if you're interested in doing this kind of stuff, get connected with, because there are folks just like yourself who are working with this stuff every day. I'll answer one more, and I'm going to run out of time here. But again, I'll just say, email me if you have questions. Always happy to help. Reach out to me on any platforms. Luis Berrieza says, how can advanced statistics be brought to foreign leagues like Mexico or the Dominican Republic? A lot of the advanced data collection that's happening now is based, as you know, on technology that's physical technology that's installed in the stadiums. 25 years ago, we gathered data by having people sitting with pen and paper, or eventually laptops, I suppose, and typing in things as they happen. Now we've got camera systems with machine learning and AI. We have radar systems that are collecting all of this data. One of the cool things is that in recent years, that's trickled down to a lot of the minor league stadiums. A lot of colleges are starting to use that. And of course, you can get, for training purposes, you can buy a Rapsoda machine for a few $100s. I know there are high school teams that use that to gather that kind of data. So that those possibilities are out there. I think we're going to see over the next 3 or 4 years, we're going to see a lot more of that technology getting deployed, particularly in the Dominican, but in other places as well. So I'm going to leave it at that. We're up at the top of the hour. Thank you, everybody, for joining today. Appreciate you all starting this journey, and good luck. And as I said, please feel free to reach out if you have other questions. Be happy to help.
Sean, thank you so much. Wonderful as usual. We appreciate you leading us off. Again, Sean is a great resource. He's a legend in the baseball database universe. So we're lucky to have him here. And again, SeanLahman.com is a good place to start. And everybody who's going to be presenting today is incredibly accessible and willing to donate their time to help out with folks just starting their journey. So thank you so much, Sean.
Thank you, Scott.